All right, Chapter 10, Section 5, and this is going to be all about something called a tangent. So you've heard this word a lot with sine, cosine, and tangent, and you've seen it before, but we're going to talk specifically about what a tangent is. So first thing we'll do is define the word tangent. A tangent is a line that intersects a circle in exactly one point, and that point is called a point of tangency. So that's important to recognize, point of tangency. We're going to draw a picture. So here's our circle. It's going to have a center, so circle C, and we're going to draw a tangent, which is going to look like this. And our tangent is a line, so it'll be line L, that intersects a circle in exactly one point, so right there, called the point of tangency, so that'll be point P. So the way we talk about this is to say L is tangent to circle C at P. Okay, so you want to be able to recognize this kind of statement or write this kind of statement when you're describing a picture like this. A tangent. Something that you also are going to see is something called a common tangent. So common means that two things have something in common, or multiple things have something in common. So a common tangent is just tangent to two circles. And there's several ways that can happen. We're going to make a few pictures here. So one way that it can happen is that you can have one common tangent. And what that'll look like is to have a big circle and then a little smaller circle inside it like that. And your common tangent will be this point or this line that only hits one point like that. So that'd be an example of one common tangent. There's only one place that those two circles have the same tangent. So we can have two common. We have a large circle, and then we have a little bit smaller one. And so they each have a line that's tangent to them, but there's two different ways it can happen. Okay, then we can go to three common. A big circle, and then this one's going to be similar to the last one. Okay, so we have our two common ones just like the last one, but hopefully some of you are seeing we can have a third one that goes right between them like that. So they're both tangent to it right there. So that's three common tangents. And we're going to do four. It'll be four common tangents. That's when you have two circles that actually don't intersect at all. So we're going to have one here and one here. So we start making our common tangents. So we have these two, But then there's two more that we can also have. They may not be as easy to see, but there is this one and this one. So again, more tangent lines. And it's not, you're not going to have to draw these and do a bunch of calculations with it or anything weird. It's just that you can understand where they go and what they are. And the last possibility is that you have no common tangents. Okay, so how can we have two circles that never have at least one common tangent? Well, the only way is if they are one here and the other one inside it completely. So you can see that there's no way that we could draw a line that only intersects each of those circles one time. If we do one that hits the red circle one time, well, it hits the blue circle two times. So there's no way we can do it. If we do one that hits the blue circle one time, it hits the red circle no times. So that's how you have no common tangents. Something super important, and this is a big thing to remember out of high school geometry when you move on to pre-cal and calculus, is that tangents are perpendicular to the radius. And that may not seem logical to you when we look at a first picture, but it's an important thing that we want to try to get down. So we're going to do a quick example. So we have an example. We have circle C. And we're going to draw a little picture on it. So there's going to be a radius. That's going to be a tangent. So this is an example of the kind of things we can figure out. We'll say that our radius is unknown, so it's going to be x. We don't know how long it is. And this is going to be 12. And from this point on the circle out to the end here is going to be 8. And our problem is to find out what x is. Well, if we know that this is a tangent, that means that this has to be perpendicular because tangents are perpendicular to the radius. We also know that from C to this edge here, well, that's also x, even though it's not listed because that's a radius, just like up to here would be a radius, or anywhere from the center to any edge would be a radius. So if we look at our picture here, we really have a right triangle, and this hypotenuse for a right triangle is really x plus 8. That's how long it is. So to find out what x is, we can say that x squared plus 12 squared equals x plus 8 squared. And so if we didn't know how long the radius was, or we were trying to build some kind of pump or design some kind of machine or work with something in the physical world, and we needed to know that radius so we knew how big to make the circle or how big to make something on the pump, we could figure it out by doing this. So x squared plus 144 equals, now x plus 8 squared is really this, right? So if you do FOIL, that gives you x squared plus 8x plus 8x plus 64, which is x squared plus 16x plus 64, right? So all this just comes down, so it's still x squared plus 144. Now to solve this, we need to get everything, all the x's on the same side. So we'll subtract x squared from both sides, and super conveniently, those all eliminate each other. Now we have 144 equals 16x minus, or plus 64. So we just go with our simple algebra now. So we get 80 equals 16x. Divide both sides by 16, and we get that x equals 5. So that's our radius, was 5. Not too hard to figure out, but still a little more challenging problem than maybe we're used to. Last fact, and this is just kind of a fact that it'll pop up in problems, and it makes them it's easy to use and it makes the problems easier to do. So if two segments from the same point are tangent to a circle, then they are congruent. Okay, so quick picture, and we're done. So circle. So if two segments from the same point, so here's a point, so it'll be point A, are tangent to a circle. So now we need two segments from that point that are tangent to that circle. So there's one, and here is the other one. Now notice I drew longer lines, right? I went past it because a lot of times you're going to see them. They're going to be longer than what you actually use. But if we go from here to here, so this segment AB and this segment AC, those two segments are congruent. Okay, all of this doesn't matter. This could go on forever. We don't care about that. What we care about is the length of these two segments, and they're always going to be congruent. So that's it. Have a great day.